So friends, question number 7.14, problem number 7.14, chapter number 7. Species are given H2O, HCO3 minus, HSO4 minus, and NH3. This is based on Bronsted-Lowry acid-base theory. So the name of the topic is Bronsted-Lowry acid-base theory. So this question is based on this topic. Now what to do? We have to make, or we have to find out the corresponding conjugate acids and base of the given species. So first of all, we have to write the species. So you can see here the species are, first one is H2O, second one is HCO3 minus, third one is HSO4 minus, and fourth one is NH3. As per Bronsted-Lowry acid-base theory, when we want to convert any species into conjugate base, we have to remove one H plus. We have to remove one H plus to make conjugate base. And this is, you have to keep in mind, remove one H plus. As well as friends, when we are removing one H plus, the charge will be -1 from origin or original charge. So original charge, whatever given, you have to subtract 1 out of the given charge and you will get the conjugate base. For example, friends, H2O is given. H2O is to be considered acid. In that case, its conjugate base can be obtained. This is H2O, and think minus H plus. Removal of H plus. So what will left? The left part will be OH. What is the charge of H2O? It's 0, right friends? So here we have to put 0 minus 1. So -1 charge is there. And if you think, friends, in H2O, already H plus and OH both are present. H plus is donated because conjugate base require removal of one H plus, and that's why the OH minus will left. It will have -1 charge. Now, friends, what to do to make the conjugate acid of the same H2O? So just like here, remove one H plus. Here we have to keep in mind, add one H plus and add also +1 charge to the origin. Here we have subtracted 1. Here we have to add +1 charge. So H2O is there, and here we will have H3O plus. How H3O plus? It's H2O plus H plus. So H 2 plus 1 3 and O H3O and +1 charge. So this is H3O plus. It is to be said conjugate acid of H2O, and OH minus is to be said conjugate base of H2O. Now friends, similarly, let's go for the HCO3 minus. Once again, our task is similar. HCO3 minus is there. To make its conjugate base, we have to remove H plus. So look at here. This is already, we have HCO3 minus. HCO3 minus we have, and H plus is to be removed. So this H will remove, and CO3 will be there, but CO3 is charged. This is -1, and we have to make one more minus, subtract one more minus. So total charge will be -2. -1 is here, -1 we have to remove. So this is CO3, 2 minus carbonate ion is conjugate base. Now friends, if we want to make the conjugate acid of this, similarly we have to go for the addition of H plus. Our origin is HCO3 minus, we have to add plus H plus, this is add H plus H, that is H2 and CO3. So our answer is H2CO3. This is minus one charge, this is plus one charge, total becomes 0, and that's why H2CO3 is a conjugate acid of a species HCO3 minus. Similarly, friends, for H2SO4, from HSO4 minus, we have to subtract one H plus to make its conjugate base. HH will remove, and SO4 2 minus. So sulfate SO4 2 minus, removal of H plus gives us SO4 2 minus, which is conjugate base. Similarly, on left side, we have to add one H plus. So add one H plus. H plus H and H, H2, SO4, charge plus 1, minus 1 becomes 0. Similarly, friends, here we have to keep in mind, remove H plus, NH3 minus, friends, NH3 minus H plus. In that case, friends, we can get NH2 minus. Removal NH3 minus H means NH2. Charge was 0 and 1 is subtracted. So 0 minus 1 minus 1. Similarly, here add 1 H plus. So NH3, here is NH3 and plus H plus, it will become NH4 plus 1. So NH4 plus 1. So you can see, friends, here your answers are there. This is conjugate acids, H3O plus of H2O, H2CO3 of HCO3, H2SO4 is of HSO4, and NH4 plus of NH3. Similarly, for conjugate bases, friends, based on the similar one, remove H plus and charge will be minus 1 subtracted. Answers are OH minus of H2O, CO3 2 minus, minus 1 charge was already there, minus 1 more, so minus 1 and minus 1 minus 2. Similarly, in SO4 and all. Right, friends? So this is all about the numerical number, problem number 7.14.